now it is my great pleasure to introduce our speakers today. We will be joined by the following Digital Twin Consortium members. Doug Migliori from Event Driven Systems will talk about this multi-consortia initiative. Benzaquen from Dassault Systèmes will discuss transportation as a system of systems. And Corey Gray from Smart Cities Council will talk about how we can deliver sustainable outcomes at scale. And now I'm going to hand things over to Doug Migliori to begin this presentation. Thank you, Doug.
Thank you, Meg. Welcome, everybody. I'm excited to talk about this multi-consortium initiative, which really began over a year ago as a TM Forum Smart Airport Catalyst project, which is really a test bed that was on a 6-month sprint to develop a POC. It was really based upon a digital twin system of systems, and it included multiple consortium that joined in with the TM Forum. We had members of the Airport Council International's ACRIS work group, which is responsible for the information and data exchange standards that are applicable to the aviation community. And we had the Digital Twin Consortium as well participating in that. And then Smart Cities Council joined in towards the end. And since then, we have extended to a few other consortium that we're all trying to create alignment between different information models and data exchange standards so that we can really support cross-industry, cross-domain information exchange and eliminate a lot of friction that can end up where services, intelligence services can be selected, delivered, tested and delivered within a federated marketplace. And that can extend beyond airports, which is really our test bed because it has so many different interdependent use cases, but beyond an airport into other transportation hubs and smart city initiatives. So just putting things in context of a global challenge and how our initiative is focusing on trying to address some of these challenges. One of the key challenges is just eliminating friction between all of these interdependent cross-domain systems that form a global GDP. And the other key challenge is to incentivize data sharing between people and organizations so that you can be able to make decisions based upon more holistic and timely information and knowledge. But that requires a trusted governance that protects privacy and allows for cyber security. IBM did a study a few years back that kind of illustrates the significance of these siloed systems and how they're not working well together. And they estimated that all of those inefficiencies are resulting in $4 trillion of waste in GDP that could be eliminated by just having these systems work well together. So a key part of being able to make the right decisions at the right time requires a lot of real-time information that's available to you. And you are able to obtain that information really through events that can be broadcast out to any organization or person that's interested in an event, where an event really represents any type of state change in an environment. It could be a change in weather. It could be a change in the status of an order. It could be any status change that would be significant to a system and wanting that system to react to it in a timely manner. So that's a key part of this. And the other part is moving from where technology providers are providing a one-size-fits-all packaged application to where they're breaking out their applications into granular capabilities. Gartner will call them packaged business capabilities. But then you as an end customer, a business, can compose the systems that and capabilities that form those systems based from multiple vendors. And if a vendor isn't performing well with its capability, that you have the ability to unplug that vendor and plug in another vendor very easily. The other part of this is enabling a common understanding that ties those events to a common semantic model. And we're foundationally using the ACRIS semantic model that's part of the Airport Council International, where they've developed top-level semantics that extends into all these interdependent domains that are within an airport that's shown on the left-hand side. And key concepts that are at the top level that are applicable across any industry are listed there, from agreements to offerings. And so we're building off that and supplementing it with other data models and trying to create alignment between all those different industry consortia. And putting it all together with events and a semantic model and service orchestration and ability to maintain state and previous state will allow decision intelligence to start to predict future states. And from there, through model and simulation, is where you're able to create real-time decisions that have high impact. And the key objectives or outcomes that we're focusing on within this particular initiative within airports is to reduce the queue and wait times so that passengers are less stressed and they're more willing to spend money on passenger services, which results in more revenue to the airports. But the mobile app is a key part of this to provide a continuum of optimized experiences. And all of this is orchestrated through an eventing platform. And part of this is to evolve the common models beyond just the semantic ontology or semantic model, to where we have common models for events. We start having common models for capabilities, which is really where we still need a lot of help building out a lot of the detailed capability models to support all of these use cases within an airport and transportation hubs. And then how all of these services can come together in a marketplace where you're able to create a system of systems that's composable and interoperable. And so this is was a culmination of the work from last year within the TM Forum project, and it just again restates the key objectives of this initiative. A lot of the different goals within airports that are same goals within any transportation hub in cities. Less stress, more revenue. Really trying to take all these Industry 4.0 technologies, convert them to capabilities, make them available or accessible within a federated marketplace that can then enable composable and interoperable higher level capabilities from starting with queue monitoring all the way up to passenger and airport management. And with that, I will turn it over to Isaac.
Thank you, Doc. So first, I would like to describe what is a transportation system of system. So a transportation system is really composed by mode of operation. So really how I'm going to transport passenger or freight. Could be an airplane, could be a car, could be a train. And then what is the infrastructure that's supporting this mode? For example, an airplane will be an airport, eVTOL will be a vertiport. And then we connect all this infrastructure to create a system. And then we can really look and simulate the flow, how the interaction of the flow between all these nodes is going to happen. Now, you can look it as a global system from a country perspective, and then you can create what we call a subsystem. For example, an infrastructure could be also described as a system. For example, as we are going to see later on, an airport can be described as a system. So now you have a complex system of system on which now you can look and simulate to understand how the interaction will be look like. But also, you can also understand what happens if now you are injecting a new mode of transportation, for example, eVTOL, how it's going to impact my network, but also run different use case scenario and understanding to, for example, CO2 emission, noise emission, as we can see later on. Next. So to illustrate that, we are currently working on a PhD research project. We are supporting a PhD research project, and it's done in France. So France have a lot of small airports, and what they want is to analyze if the transportation network in France can accommodate all the small cities and country to, for example, to connect to an international airport easily. So what they did, we modelize as a system of system. And now what you want is really to understand if all these vertiport, all the small airport are effective. Maybe we need to close and open in other cities and really optimize the network. And then, of course, understand with the new technology and new transportation how France will look like in the next years with air mobility and everything like that. Next. So really, now that we have the description of the country, now we can drill down to a subsystem, and this is what you're going to see here. We really modelize a vertiport, and what we're going to describe as a system here, what we call a system of operation, how we really a vertiport is operated. So to explain, a vertiport is the airport for air mobility. And then we can really understand how all the function, logically, how everything is interacting within the vertiport, but also we can expand the vertiport with interaction with the cities or interaction between a vertiport and an airport. All these are systems that can be also connected and create a huge system of system. The objective of this system of operation demonstration that we built is to define the optimal configuration of an airport or vertiport to meet a cost per the most effective cost per passenger. So really what we want to understand is, as a mode of operation, how much will cost to operate if I add another pad, a landing pad or not, or also in the context of a city, how much will cost, how much passenger I will be able to meet. But also I can inject to the system different type of transportation. For example, I have a lot of different eVTOLs. Each eVTOL have a cost of operation different. And then you can inject to the system and understand how the system will behave. So really having a system approach gives you a great understanding from a logical and functional perspective, how the system behave, and you can run a lot of simulation. This is what we call a 0D, 1D simulation. Next. But I think that system need also to be integrated into the digital twin. It's bringing additional value to the system because system can simulate in the 0D, 1D. Now you have a lot of impact and understanding in more 3D world, like the noise simulation, as you can see below. The video below describe a study we did on installing a pad, a small vertiport near the Eiffel Tower, and what will be the noise impact to understand the surrounding, where is the best place to put it, but also how it's going to impact the people living around the vertiport for acceptance and everything like that. And the one that you see operates as another study we did around how we can minimize noise around, the highway. So you can run simulation on what is the noise and then be able to build some wall and understand how this wall will absorb the noise. So really integrating a system approach with digital twin provide you a really a broad understanding and help you to improve your decision making. This is what we call the 0D 3D simulation. Now, by integrating a system to a digital twin, really you can now expand your understanding and improve your decision making. Thank you.
Thanks, Isaac. So what I want to build out now, I guess, is a sense of what this all means for us as a practical level and how we can go about applying this technology and the benefits that can be delivered to us. So as I said, what we want to be able to do now, the beauty of what we have now with this digital twin system of systems model is two things we can do. One is iterate and enhance and optimize the performance of assets. And then to Isaac's point, with a rich source of data, we can also model future mobility, such as vertiports, changes to an airport, maybe a new type of airline or other functions and features as we go. So where we've got to at the moment and where we want to take to action is we've started with airports, as Doug's mentioned, and we have a positioning around the passenger experience. We now then want to be able to move from the passenger experience onward to freight and other modes of transportation, as Isaac talked about. So as part of this process at Smart City Council, one of the things that we are helping to do with this project is to build that capability and capacity. So we're talking about standards through ACRIS, as Doug's mentioned. We're talking about building playbooks so that airport owners and operators have a clear path how to move forward in a standardized, data-driven, technology-enabled airport on a digital twin platform, project design and credentialing tools, and then a federated marketplace, as Doug's mentioned. So when we now look at the global need for transportation hubs and I guess mobility, what I've just done here is highlight a few of the different projects that are directly relevant to this work. And one of them I'll tease out in a minute, which is the CPK project in Poland. But that's a project, for example, which is a main new airport, 2,500 kilometers of rail. Ultimately, there's road connectivity. So the need for a standardized approach here to deliver those efficiencies, and we want to remember that what we're trying to achieve, as Doug said at the outlet, is more economic activation for the airports, but we also want to reduce the cost of operation. We want to reduce the risk of operation, and we also want to be able to provide environmental and social benefits, better user experience for customers, for staff, for contractors, reduce carbon emissions, and so on. So as you can see on the screen, I've picked a few different projects. In Ukraine, for example, I think we're all aware of the devastation there. There's $1 trillion of reconstruction required. It's effectively going to be building a new country. Through Africa at the moment with Charter Cities Institute, there's 33 greenfield cities to be built where all of these principles and processes can be and will need to be applied. In my home country of Australia and with New Zealand, there's $200 billion of transport and infrastructure projects now for which this work is directly relevant. In New South Wales, $15 billion project with seaports, rail and airports connectivity. And then if we move over the slide now, Doug, I'll be able to take people through an example, which is actually the biggest infrastructure project in Polish history that our organisation in Warsaw is starting to work with. So the CPK project, as I mentioned, is a new airport with rail hub connectivity just outside between Lodz and Warsaw. It's about a €7.5 billion project. And again, this type of approach and standardization that takes our original work from being, as I said, just airports to connectivity between airports with rail, with road, and also the final connectivity to the city for people and freight is a really important next step for the work that we're doing. As again, to Isaac's point, that system of systems approach allows us to uniquely optimize the performance of existing assets, but also reliably predict what happens to assets in the future as we might add new systems or new requirements and new modalities of transport. Yeah, okay, so the integrated passenger transport model is a really, I guess it's an example of exactly what we're doing. It's allowing the people that are designing and delivering this project to access real data, event-driven data, and to understand the consequences of the design approaches that are taken, the impact, I think, on of the changes that are going to be made over time, because obviously we're talking about multi-generational investments. So by having a data-rich and living model, the project designers, as I say, can reliably model, for example, the vertiports, model different systems, model different passenger and freight loads, and balance them all out to provide an ideally optimized outcome. So the artificial intelligence and the decision intelligence around all of this is very important. And I think there's a heavy focus on machine learning at the moment. One of the things that we can see coming at the end of this is actually machine teaching, where if we have a standardized model for airports and we have a interoperability and cyber-secure data exchange, we can, with extreme precision, provide information from one asset to another, potentially, to allow mistakes to be avoided or assumptions to be validated as we go forward. So using this digital twin-enabled system of systems model, by creating standardized playbooks, by creating efficient documents for contract procurement, project design that allow for interoperability and innovative procurement models, as a group of or a multi-consortia initiative, where, as I said at the beginning, building capability and capacity on the client side, but also building a federated ecosystem and very standard procurement processes on the vendor side. And I guess to close, at a recent summit when we were talking about $200 billion of infrastructure investment with government, at the initial stage of the project, private sector was pricing in something like 30% of contingency for trying to deal with traditional procurement projects around an innovative technology platform. Now, obviously, if we can get that $60 billion down to 2 or 3 or even 5, then we're providing significant citizen and environmental benefit. And that's just another one of the, the really high value outcomes that we want to achieve from this project.
Any final words before we end our presentation? Let's start with you, Corey.
I'll just speak briefly. There was one question about cyber standards, and that's something that we're looking at very carefully through Smart Cities Council. There's recently been a new Department of Defence, CMMC, released. We see that as being a really strong positioning around cybersecurity that could become a de facto standard for this project and for other public and private sector work as well. But yeah, that there's a whole work stream, just to speak to the gentleman who raised that point, that will work in at least what we're doing under and around that critical aspect. Because the value of centralizing and aggregating data is you can analyze it. The challenge is that point of failure, and we also face with airports, edge definition around cybersecurity, which can get murkier once you're adding many millions of nodes and devices. So that's front of mind, that topic.
Thank you. How about you, Isaac? Any last comments before we sign off?
Yeah, I think my only comment is that digital twin is becoming a de facto standard. Everyone is engaging on that. So if you didn't start, I think I really strongly recommend to start thinking about what digital twin mean for you and how you can start engage on that.
Thank you. And Doug?
Yeah, I agree with Isaac. The digital twins are becoming part of every conversation, and you start connecting them together through governance that establishes interoperability and trustworthiness. Then you can start to address much higher level challenges through what they call an industrial metaverse, which is really founded on connected digital twins. So very exciting times, and I'm glad to be a part of this.
Thank you again. Thank you to our presenters. Thank you to the audience, and everyone have a great rest of your day.